Okay, so in the last class, we have discussed about physical world, first unit of physics in this class. Let us brief what's topic that we have to discuss about in this section. First thing is what is science that we have to know. Next one is steps involved in scientific method. What is scientific method? And thereafter, what is physics? And after that, we will discuss about the scope and experiment of physics, and then physics and technology and society. After that, fundamental forces in nature and nature of physical laws. So these are the 7 points that is to be discussed. So let us first we discuss the first point. What is science? So you all of you must be knowing that the word science originates from the Latin word scientia, meaning to know. So the knowledge which man has acquired through observation and experiment, when organized systematically, such knowledge is called science. So men during their struggle acquired so many knowledges from his their experiment, experience, observation, and when all these experience and observation compiled systematically, then began science. So scientia means to know. Now, the science which deals with the non-living things, science can be subdivided into two subcategory. One is living science and another is non-living science. That is physical science and life science. So science which deals with non-living things are called physical science. Example of physical science are physics, chemistry, geology, geography, astronomy, astrology, and oceanology. All these branches of science has nothing to do with the life, and it is not associated with living things. That's why these are the branches of science that calls physical science. Now we have another branch of science which deals with the study of living things. That is called life science. So life science can also be subdivided into two categories. One is zoology and other is botany. Zoology is the branch of life science that deals with the study of living organism, animals, etc. On the other hand, a branch of science which deals with the study of plants. Plant is also life, therefore it is also a branch of life science, but its behavior is different from that of the animals. That's why we need a separate branch to study about plants. So this is called botany. Next, thereafter, another topic that we have to discuss first, that is physics. What is physics? Someone may ask you, what is physics? The word physics comes from the Greek word physis. which means nature. Physi means nature. And it was introduced by the ancient scientist Aristotle. So, as you know that man has always been fascinated by nature, so he questioned and a short answer for every phenomenon that occurs in nature. So, in brief, now we can define physics. Physics is the branch of science which deals with the study of nature and natural phenomena. It is expected that all the events in nature takes place according to some basic laws. Physics reveals these basic laws from day-to-day observation. When you observe any phenomenon very minutely, then you will conclude that every phenomenon in nature undergoes by obeying certain basic laws. And that laws becomes law of physics and law of nature. So it is essential that now a step involving in scientific method. Next one is method to be discussed. If you observe anything scientifically, first step, what would you take about that? Say, uh, flow of river is there. Then you have to think about flow of river. Question yourself about why river flows, and then you will search the answer. So first thing is that observe anything and then question how, why, which, when. So, and try to ponder about the answer to that question. So, first step to think about scientifically is to question yourself about any natural phenomenon. And after that, search out the answer to that question. So, in order to search out the answer to that question, do background research. That means you must research behind that question. Your research must be around that question. And in order to research, you need to construct hypothesis. First, we take hypothetically any phenomenon because at that time we don't know the laws, but we try to correlate certain hypothetical laws with that phenomenon. And after that, we think again and again. So then we try to understand whether hypothetical or hypothesis related to that question or phenomenon is true or false. For that one, you have to test with an experiment. After testing, analyze the result, draw the conclusion. So conclusion could be either true. Hypothesis is either true, that we have uh, made the hypothesis about that phenomenon. Whether it is true or it is true or partially true. It is true or partially true or false or partially true. Now report the results. If it is partially true, then just think and again and try to construct another hypothesis regarding that phenomenon. And one day, and one of the hypotheses that you have framed will be true and match with that phenomenon. Then this hypothesis becomes law of physics. And then this hypothesis will explain that physical phenomenon. Now question is that the knowledge of physics accumulated till 1900 is called classical physics that deals with the macroscopic phenomena. It includes a subject like mechanics, thermodynamics, electromagnetism, and optics. So all these were the classical physics because these were studied much earlier before 1900s. Now, beyond 1900s, whatever the physics came into picture was termed as modern physics. And modern physics consists of two basic theories. First one is a relativity, theory of relativity, and second one is quantum mechanics. That you will study here a little bit about quantum mechanics in chemistry, that is quantum number and many things else you will study. But in higher classes, you will study the what is quantum mechanics. So quantum mechanics is so important that it can deal with the study of microscopic system as well as macroscopic system. Microscopic system like atomic structure and as well as galaxies, macroscopic system, galaxy and star system and etc. So we have discussed about the branches of physics and what is physics. And now next third point is to be discussed about the scope and excitement of physics. So we people are in the habit of thinking that anything that we are interested to do can do only when that action, that activity, whether benefit to us or benefit to our society or this world or not. So if someone asks you study physics, first question is that why should I study physics? Why should we study physics? What is the scope of this physics? What is benefit of physics to our society, to our uh, civilization, to the world, to the humankind? So the scope of physics is very large. Physics deals with a wide variety of disciplines such as mechanics, heat, and light. Now, a study of mechanics helps us to know the force involved in the flight of bird, walk of man, and so on. In class 9, you would have studied that anything at rest continue to be at rest, or anything moving uniformly will continue to move uniformly until and unless some external force act on it. Here, we have to deal that any object which is at rest starts moving. We observe that object starts moving, but we don't think about the which factor causes to produce motion in that object. This is nothing but what force. So every movement involves action of force, whether stars, galaxies, birds, and water rivers and tides in the oceans, all are moving. All these are inspired or correlated with a certain kind of force acting behind that. Next, to study heat, help us to. So remember, a scope of physics we are just discussing here. A scope of physics is very large. Physics deals with a wide variety of disciplines such as mechanics, heat, light, and astrophysics that we deal with the astronomy, as well as biophysics, and so geophysics. Everywhere we apply physics. Therefore, it has a wide variety. That's why its scope is vast. In order to understand that one, let us, what do we study in mechanics? What information do we get from mechanics? Mechanics inform you about the force that involves in the motion of any moving body. Next, another branch of physics is thermal physics, in which we study about heat. And this branch of physics is called thermodynamics. So try to understand here the a study of heat help us. Hello. The study of heat help us to know about the rise and fall of temperature, working of heat engine, and so on. So this is the scope of thermal physics. Now,
Yes, sir. Good evening, sir.
electricity helps to understand the basic principle involved in generators, motors, and the exciting discipline of modern physics takes us into the microscopic world of atoms and electrons. Now, distribution of charges proposed by Thomson in his model was tested by Ernest Rutherford in 1909 by using subatomic projectiles to bombard a target of atoms. And these projectiles called alpha particles and were identified as one of the products of the radioactivity. So this is what I spoke. Now Rutherford's famous alpha particle scattering experiment is represented in the figure above. So a stream of high energy particle from radioactive source is directed to a thin foil, gold foil metal having a circular fluorescent zinc sulfide screen surrounding it. So whenever alpha particles strike the screen, a tiny flash of light is produced at that point, indicating that the alpha particle strike at that point, so we can trace out their path and deviation. Next one is relation of physics to science, society, and technology. How physics is related to science, society, and technology. This is the
Sir.
important. Yes. क्या
तुम अभी कुछ टच की क्या?
हम कुछ नहीं किए। नहीं।
तो फिर सर का कैसे हट गया?
सर का हट गया। आगे सर पढ़ा रहे हैं।
मेरे में नहीं आ रहा है, मेरे में तुम आ रही है। भागो तुम यहाँ से।
बस। हम क्या किए? हम कहाँ कुछ किए हैं? यस सर।
या तो वहां से कुछ किए हो, ये ध्यान देना है।
नो सर, कुछ नहीं।
ओके।
सर आपका पिक्चर आ रहा है लेकिन वो हट गया।
यस सर।
Now try to understand. Is it okay?
नो सर, कुछ नहीं।
Okay. So among the various discipline of science, the only discipline among the various discipline of science, the only discipline which can be regarded as being most fundamental, that is physics. It is most played key role in the development of all other discipline of science. For example, physics in relation to chemistry, how physics or concept of physics help to develop chemistry. So try to understand here. To study the structure of atom, radioactivity, X-ray, diffraction, etc. in physics. Although all these phenomena are studied in physics, but helps in evolvement of laws of chemistry. So in physics, has enabled the chemist to rearrange elements in periodic table and to have a better understanding of chemical and complex chemical structure. Now, physics in relation to biological science. How physics or knowledge of physics help to have a concept of biological science is that one. The optical microscopes developed in physics are extensively used in the study of biological sample. Electron microscope, X-rays, and radioisotopes are all used by widely in medical science. Therefore, physics is also helpful there. Now, physics in relation to astronomy, you know well that nowadays our civilization is hoping that we will be there at Mars and beyond solar system. This is on account of concept of physics that our civilization is knowing and trying to know right from the primitive age. So the giant astronomical telescope and radio telescope have enabled the astronomers to observe planets and other heavenly objects. And all these lectures will be available on YouTube today. Right from today, you can search over there and you can look it again and again. So physics related to mathematics. Now come to the point. Physics related to mathematics. Mathematics has served as a powerful tool in the development of modern theoretical physics. So math is the language of physics. Without math, one cannot know physics. And as well as physics is the significance of maths. Knowledge of math can be applied while studying physics. Physics related to sciences. Now, the other sciences like biophysics, geology, hydrology, and oceanography and seismology use some of the laws of physics. So, don't worry. Physics related to society and technology. Now we come to know that how physics is related to our society and development of our society. So development of telephone, telegraph, and telex enable us to transmit messages instantly to distant place. The development of radio, television, satellites has revolutionized the means of communication in our civilization, and advance in electronics, computer, calculator, and laser have uh, greatly enriched the society and changed the lifestyle of the society. And rapid means of transport are important for the society. Now, a day we can go from Patna to Delhi within hours, and generation of power from nuclear reactors is based on the phenomenon of controlled nuclear chain reaction, and digital electronics is widely used in modern technological developments. Everything is digital right now in modern era. So all these are on account of the concept or evolvement of various laws of physics. Now, new topic is basic forces in nature that we have to study. I think that today uh, only 40 minutes can take this session. After that, automatically it will be closed up.
Yes, sir.
So, and then I will upload it on the YouTube. You can view it again and again. Okay.
Yes,
Now,
sir.
hello. Yes. The basic forces in nature. फर्स्ट बेसिक फोर्सेस, जैसा कि मैं प्रीवियस क्लास में भी डिस्कस करता रहा था कि देयर आर थ्री बेसिक फोर्सेस, फंडामेंटल फोर्सेस इन नेचर: ग्रेविटेशनल फोर्स, इलेक्ट्रिकल फोर्स एंड न्यूक्लियर फोर्स. So try to understand. Gravitational force is a basic force, fundamental force. It is the force of attraction between any two bodies in the universe due to having mass in the body. The gravitational force is inversely proportional to the square of distance between the two bodies and directly proportional to product of masses of the two bodies that you would have studied in class 9th. Gravitational force is small when light bodies are considered and is considerable when massive bodies are taken into account. Mathematical formula for gravitational force, all of you are already familiar with this one, is that F equal to capital G m1 m2 upon r square. So far it is just a brief discussion about that fundamental force. Another fundamental force is electrostatic force. That force arises due to charge. So it is the force between two charges, just like masses. Gravitational force was the force between two masses. And it is a stronger than gravitational force. This is much more stronger than gravitational force. So electric force is said to be a strongest force of all the three fundamental forces. So it also follows inverse square law and is proportional to product of the point charges. And it has physical format similar to that one in physical formula. There, capital G, m1, m2 upon r square. Capital G was proportionality constant and m1, m2 was mass. Here, mass is the property of matter. Here we take another property of matter, charge, Q1 and Q2, and inversely proportional to a square of distance. Same thing is there. Only difference is that mass is replaced by charge and gravitational constant is replaced by K, proportionality constant, and K has certain value 1 by 4 pi epsilon naught and numerical value equal to 9 into 10 to the power 9. Now magnetic force, another kind of force. It can be either attractive or repulsive. It can be force between two magnets or force on a magnet placed in a magnetic field. So this is also a kind of force. Electromagnetic force, the combined force due to electrical and magnetic is called electromagnetic force. Although electrical and magnetic force both arises due to charge. Electrical force arises due to charge, whether charge is at rest or charge in motion. But magnetic force arises due to moving charge. So an electric charge moving in a magnetic field experiences a force. And this is called electromagnetic force. And it is combination of electricity and magnetism. So, and this branch of science can be said to be electromagnetism. Next, nuclear force. So remember, only three forces are there, which is fundamental. Although here you are studying more than three forces. One force is here gravitational, another force is electrostatic force, and here magnetic force, electromagnetic. So only this force can be treated for this one. Electrostatic force and magnetic force, when together mix up, that is called electromagnetic force. So you must write a gravitational force, electromagnetic force, and then nuclear force. Only three forces. Okay. And when you explain electromagnetic force, then you can divide it as electrostatic force and magnetic force. Nuclear force is the strong force with the short range. This force is strong only within the short range, that is within the dimension of atom. And it is non-central force. So far, electrical force and gravitational force were central force. So this is a strong force with short range and it is non-central force. It is directed along the line joining the two center of the interacting particles. That's why it is non-central force. And this force acts within the nucleus only. And outside the nucleus, this force becomes negligibly small. So within the nucleus, this force is the strongest of all other forces. But outside the nucleus, it becomes weakest of all forces. Therefore, we say short range force. Now come to the point weak force. Nuclear force can further be arranged. And here we, out of three fundamental forces, we have to check out which one is the strongest force and which one is weak. So weak force, this kind of interaction is not well understood as yet. So its range is shorter than the nuclear force. There is another kind of force. Nuclear force further subdivided into two categories: weak nuclear force, a strong nuclear force. So within the nucleus, that force exists, that is called a strong nuclear force. But within the subatomic particles like neutron and proton, a kind of force also acts there, that is called weak nuclear force. So it is important only for certain nuclear process like radioactive beta decay and a strong electromagnetic, weak gravitational. So ratio of these forces are look at here. A strong electromagnetic, strong is electromagnetic, then weak force. Weak force is what? Gravitational. So when you arrange all this, their sequence will be like this. So most strong force is 10 to the power 2, that is electromagnetic. And then this one, and then. So a strong force, electromagnetic force, weak force, gravitational force. Next, comparison of electrostatics and gravitational forces. A point of similarities. They are central force, gravitational or electrical forces, electromagnetic forces are central forces. Both of them obey inverse square laws. They are conservative forces and they operate even in vacuum, and they are long range forces. They act from 0 to infinity. And point of dissimilarity is that all these were the similarities, point of similarity. Dissimilarity क्या है? कि gravitational forces are always attractive, while electromagnetic force can be attractive or repulsive. Next, gravitational force has constant proportionality that doesn't depend on medium, while electrical constant depends on medium. Therefore, electrostatic force are extremely large as compared to the gravitational force. And next, law of conservation that we will discuss about. Various law of conservation is there. So we will discuss about law of conservation. And that's enough for this chapter. Clear? And then you will have some assignment that you will have to do. Till then, इसको भी डिस्कस करके इसको फिनिश ही कर देते हैं, देखते हैं.
Yes, sir.
Okay, so now come to the point. हमने अभी डिस्कस किया कि जो 3 फंडामेंटल फोर्सेस था उसमें से कंपेयर करना था हमें ग्रेविटेशनल फोर्स और इलेक्ट्रिकल फोर्स को. तो कंपेयर में हमें क्या सिमिलरिटीज है, क्या डिसिमिलरिटीज है, वो चेकआउट करना था. ये आप याद रखिएगा. Now, laws of conservation. There are nearly 14 laws of conservation based on symmetry principle in physics. All laws of conservation exist due to symmetricity of space and time. Anything that happens must not be forbidden by a conservation law. Some of important ones are as follows. अब देखिए, जो कुछ भी हो रहा है वो कहीं ना कहीं कंजर्वेशन को फॉलो कर रहा है. और कंजर्वेशन किस वजह से? ड्यू टू सिमेट्रिकल प्रिंसिपल ऑफ और एग्जिस्टेंस ऑफ स्पेस एंड टाइम. लॉज ऑफ कंजर्वेशन ऑफ लीनियर मोमेंटम, ये क्यों एग्जिस्ट करता है? इफ नो एक्सटर्नल फोर्स एक्ट ऑन द सिस्टम ऑफ कोलाइडिंग ऑब्जेक्ट, then total momentum before collision is just equal to total momentum after collision in the same direction. This is law of conservation of momentum. Next, law of conservation of inertia. Inertia can neither be created nor destroyed. It can only be transformed from one to another, one form to another form. ये भी कंजर्वेशन प्रिंसिपल है, लेकिन ये सभी कंजर्वेशन किस वजह से एग्जिस्ट कर रहा है? आगे देखिए, लॉ ऑफ कंजर्वेशन ऑफ एंगुलर मोमेंटम, जो कि इस क्लास में पढ़ना है. If no external torque acts upon the system, then angular momentum of the system remains constant. And last one is conservation of electric charge. So total electric charge of an isolated system remains constant. It can neither be created nor be destroyed. तो ये सभी कंजर्वेशन प्रिंसिपल था, और ये सभी कंजर्वेशन के पीछे क्या कारण है तो ये समझिए. There are nearly 14 laws of conservation based on symmetry principle. And this law, conservation law, exists because of symmetricity of existence of symmetrical existence of a space and time. That's why it is conservation law exists. Next, for now, that's over. Next class, I will discuss about new chapter, and you will see this on YouTube channel today.